While there are many efforts throughout the world dedicated to taming climate change, there is an additional action that can be undertaken, one not aimed at managing the weather itself. Instead, this action is aimed at constructing buildings that can survive extreme weather. It's simple, inexpensive, and perhaps best of all, immediate. Better buildings, more survivable buildings, can be constructed with one simple step: the use of a resilient, shock-absorbing adhesive applied to certain areas in wood frame construction. That is what researchers at Western Michigan University's Bronco Construction Research Center in Kalamazoo, Michigan set out to prove. And test results show that the use of specially formulated adhesive in the right places can bring remarkable results. Lead investigator Dr. Bilal Al-Hawamdeh and his team are running a monotonic test on an 8x8 wall. This is one in a series of tests that were conducted to determine the benefits of using an adhesive in light frame wall construction. Previous tests involved walls constructed with 2x4 studs and 3/8-inch plywood sheathing in 3 different configurations: nails only, nails combined with commercially available polyurethane adhesive, and nails with a specially formulated polyether adhesive called Climate. These were tested using a dynamic testing method. As the graph shows, results of dynamic testing on these 3 wall specimens were striking. It required more than 9,000 pounds of force to break the wall assembled with Climate adhesive. The nailed assembly failed at 4,000 pounds. But the story is about more than strength. The ability to absorb energy, to displace it, is critical to a wall surviving the dynamic forces of a hurricane or seismic event. The 3 2x4 walls were also measured for their displacement properties. These hysteresis curves show the lag between the force applied and the wall's response to it. The greater the lag, the better the system's ability to displace force. For the nails-only wall, the loops remain relatively close to the horizontal axis. This is due to nail slippage as force is applied, known as pinching. The specimen consisting of nails and polyurethane adhesive, labeled Adhesive A, shows better displacement than the nails-only wall, and while it is strong, it is also somewhat rigid and limited in its ability to dissipate force, resulting in relatively brittle failure compared to Adhesive B. The large area within the Adhesive B Climate hysteresis curve, with its many high-volume loops, shows an extraordinary energy-absorbing capacity. The test being conducted here in accordance with ASTM E2126 involves a wall constructed with nails and Climate adhesive. The wall specimen, composed of 2-inch by 6-inch studs on 24-inch centers, is a configuration that allows for an increased insulation cavity, thus providing superior R factor. It is also a more efficient use of wood because of the need for fewer studs. This specimen will undergo dynamic forces, or cyclic loading, intended to represent the impact of a high wind event. Previous testing on an identical wall assembled with nails survived only 4,200 pounds, or 4.2 kips.
The purpose of my research was to investigate the effectiveness of the elastomeric adhesive applications into light frame shear wall wood construction. So the purpose was to evaluate the shear strength and the shear stiffness and the ductility of different components when the adhesive are applied into their connections. So the overall goal was to ensure a continuous load path into those structures from the highest points, or from the points where the loads are subjected, all the way down to the foundation level and into the ground.
The testing machine consists of a top-mounted 20,000-pound double-acting hydraulic actuator, a steel loading beam at the top, which includes a roller system to contain lateral wall movement, a steel base channel, and bolts attached to the shear wall sill plate. Displacement measurements are taken at the top and bottom plates and end studs. Laser sensors are used to record the uplift displacement at the end studs. A special computer program captures the wall specimen's response to stress loads and movement. This is the hysteresis graph, which shows displacement in dynamic push-pull forces. The characteristic bow tie image begins to take shape.
How the nails or how the mechanical fasteners work. Nails are localized spots that can provide some level of friction between the two members. If you have, say, wind load subjected to the top of the roof, the way how it works, the loads will be, by science, needs to move and transfer from that components to the adjacent components. And if you have a gap, if you have a weak points into that path, transfer path, if you have a continuous load path, the loads can move and transfer all the way through the components down to the foundation. That's the goal.
As the load approaches 14,000 pounds, the climate-bonded wall begins to fail with a sharp crack. Most striking is that failure in the specimen occurs not along any of the bond lines. Instead, as the load path travels uniformly down the wall, the adhesive continues to displace energy until it reaches the foundation. The main wall assembly is completely intact. Failure is concentrated totally within the bottom sill plate with a longitudinal 2 by 6 inch split. This is testament to Climate's ability to absorb and dissipate energy away from construction interfaces, functioning like a shock absorber throughout the wall and delivering energy to the foundation. Once cured, Climate Adhesive has inherent high elongation properties that can reach up to 1000% without failing. That is extraordinary energy dissipation capacity. So, within the wood frame structure, connections and components can move, distributing energy instead of breaking or separating. WMU testing proves that the use of special adhesive can dramatically increase the structural integrity of light frame wall construction. The adhesive is also applicable to roof rafter construction such as birdmouth joints, which are critical to keeping roof and wall elements firmly attached under violent wind conditions. Bronco Labs continues to explore the benefits of constructing buildings with the use of flexible, elastomeric adhesive, which can function as an energy absorber, allowing buildings to survive high wind and seismic events. Of course, we must continue to develop practical issues for managing the climate, but we must also learn to construct more survivable buildings.